sir, my group member consists of Nur Natasha, Nur Intan, Melissa Lipa, and I'm Felicia. Today, our group will be presenting radar system, which is radio detection and ranging.
Hello everyone, I am Nur Natasha and this is the introduction to radar system. By definition, radar means radio detection and ranging. It is a core technology that uses radio waves to detect, locate, track, and determine the distance of objects. Radar system work by transmitting radio waves and receiving the reflected signals from the objects. Darkness, fog, rain, nothing stops radar from seeing what's out there.
Hi, my name is Melissa Lipa, and on this slide, I will present about the basic principle of radar. So basically, radar operates by using electromagnetic wave or electromagnetic energy pulses to transmit it. Specifically is the radio wave, and radar operates also very similar to the principle of sound wave reflection. Other than that, there are three steps of the working principle of radar. First, the radio frequency is transmitted and reflected from the reflecting object. When it is already reflected from an object, the reflected energy will return to the radar set again. And lastly, the radar receiver will detect the reflected signal or a small portion of reflected energy that is called an echo. By analyzing the echo, radar can determine the direction of the object, the distance, speed, height, and the position of the objects. And from the figure 1.1, we can know how operating principle of primary radar set working, which is from transmitter, duplexer, receiver, and lastly to the display.
Now these are the components of radar system and their respective functions. Firstly, the transmitter. Transmitter generate high-frequency radio waves. Next, antenna. Antenna is the component that sends radio waves into space and receive the reflected signals. Next is receiver that detects and processes the reflected wave. And finally, we have the display unit that displays information about the detected object.
Hello, my name is Felicia. I will be presenting on how radar measures distance when it's transmitted and reflected back. Radar plays a big role in measuring distance. To make reflected signal return, the radar transmits a high-frequency electromagnetic wave pulse and the recorded time taken is used to calculate the distance. Radar distance can be calculated by using c, which is speed of light, multiply time divided by 2. But why do we divide by 2? This is because we calculate the distance from when the signal is transmitted and reflected back. For example, if a signal takes 0.0001 seconds to return, how far the object is located from the radar? We use the formula that we discussed just now, where the speed of light is constant, 3 times 10 power of 8 multiplied with time taken, which is 0.0001 second divided by 2, we got 15,000 meters. Since we want to know how far the object located is, we convert meter to kilometer and we got 15 kilometer. Therefore, the object is located 15 kilometer away from the radar. Next, we go to application of radar. Do you realize in our daily life we are exposed to radar? One of it is in aviation. In aviation, the radar is used to help air traffic controllers to monitor aircraft positions and prevent collisions between another aircraft. Other than aviation, forecasters also use radar data to predict weather since weather radar can detect rain, storms, and hurricanes. Next, mariners also use radar to navigate and detect any nearby vessels, coastlines, and obstacles in front of their ships. Therefore, radar also found in traffic monitoring such as speed trap by measuring the vehicle speed and detects drivers that drive over speed limits. Lastly, in military radar, is used to detect enemy aircraft, missiles, and ships.
On this slide, I will talk about the advantages and disadvantages of the radar system. Well, the advantages of radar system is radar can penetrate mediums such as clouds, fog, and mist. Even in the presence of these conditions, data will still be collected, and the radar signals can target several objects simultaneously. Radar operate on a wider area and can target more than one object regarding of all the objects that have been targeted. Other than that, it also allows for 3D imaging based on the different angles of the object, which is why it can be used as a map on a wider area and provide 3D images of the area. Lastly, it can give the exact position and distance of an object. Radar systems use electromagnetic to calculate the distance of an object and its exact position. Other than that, there are disadvantages of radar system, which are radar can be interfered with several objects and mediums in air. Radio signals will face plenty of interference from the air while traveling to and from an object. Secondly, it can be expensive if it's used in a small area because radar systems are effective if used over large geographical areas over long periods of time. It also cannot differentiate the color of the object, which is why sometimes it will show black and white color only. Lastly, it cannot be fully resolve the targets that are blocked by a conducting material because it will be difficult for it to obtain the data regarding the target.
Now, I am going to explain about the relationship between radar with optic and wave. As all of my teammates explained earlier, radar used the principle of optic and wave since radar used radio and microwave, which is a part of electromagnetic spectrum. Firstly, radar antenna use optical principle, which is reflection, diffraction, and interference. The antenna will receive and transmit the electromagnetic wave to detect object based on the reflected signal. Next, the radar emits electromagnetic wave, which is in sinusoidal waveform. The wave from the antenna that strike the object will be in a sinusoidal waveform. Same goes to the wave from the object to the transmitter or antenna, also in a sinusoidal waveform. Other than that, radar propagates through air at the speed of light, which is c, equals to 3 times 10 to the power of 8. The round trip of the radar or wave from the transmitter to the object and from the object to the transmitter can be calculated to determine the distance or the range of the object. Lastly, radar performance is depending on the wavelength and the frequency, since each of the radar has its own frequency and wavelength and its own band. For example, X band have the frequency of 8 to 12 gigahertz with the wavelength of 2.5 to 3.75 centimeter that is used for marines and airport navigation radar. In conclusion, radar are powerful technologies that use electromagnetic wave to detect and locate objects or targets. The application in our daily life prove the importance of electromagnetic wave and the wave behavior in our society.